Welcome to today's math lesson. This is teacher Isaac here again to take you through this session. Want to appreciate you so much for watching our videos, and we want to encourage you to subscribe if you've not subscribed, like and share for more videos. And today we have brought something new, and I'd like to believe that everyone has ever looked at a box of shoes, a dice, a brick, and I can ask myself, how much space can it hold inside? How much paper would I need to wrap it completely? Well, that is exactly that we are going to learn today, and that is total surface area and the volume of tubes and cuboids. Because if you hear that how much space can it hold inside, that is the volume. Then how much paper would I need to wrap it completely? That is the total surface area. Now, that's what we are going to look at today in this video. So by end of this video, you'll be able to understand the difference between surface area and the volume. Then you'll also be able to understand and apply and use the formulas to calculate the total surface area and the volume of tubes and cuboids. Also, you will apply this knowledge to solve real life problems like packing, wrapping, and construction. So let's pay attention, and then we get a piece of paper, a notebook, and a pen to note down the important things. As I said earlier in my introduction, I said everyone is expected at least to have seen a dice, a gift box, a brick. Look at textbooks that we have in class. Look at our rubber, the boxes of chalk. All those shapes are tubes and cuboids, as you are going to see the difference between the two. And sometimes I don't know whether you have ever asked yourself, how much space is inside that box of chalk? And then I ask myself, how much paper is needed to wrap a gift box completely? On birthday parties, you always bring gifts. Wedding parties, you also take gifts. Introduction, you also take gifts. But if at all you have a box and you want to wrap it completely without leaving any space, don't just buy a wrapping paper anyhowly. At least you should be knowing the size of a wrapping paper that you should buy in order to wrap that box completely. Look at the boxes of soap. Look at the boxes of milk. All those are cuboids. If at all you see a tube, a box of equal faces, as you are going to see, then just know that that is a tube. But for the case of a box with different faces in size, then just know that that is a cuboid. They are not all different, but as you are going to see in our explanation. Now, whenever we talk of how much space is inside a box of chalk, that is volume. Then if I ask how much paper is needed to wrap it completely, we say that that is total surface area. So that is exactly what we will explore in this video. And I expect you at least to be knowing what total surface area and volume is, using the formula to find total surface area and the volume of tubes and cuboids. Not only that, but still you will know how to apply these formulas to real life problems. In the construction, you'll need volume. When, like in parking, also still you'll need volume. So we expect you at least to benefit from this lesson. Wrapping still, you'll need the concept of total surface area. Now this is our cuboid. So now when we talk of a cuboid, you can see that a vertex is just a corner. How many vertices does a cuboid have? This is the first vertex, the second, the third, the fourth, the sixth, the seventh, and then eighth. So a cuboid has 80 vertices. Vertices are same as corners. Then for the case of faces, it has 6 faces. We have this one and then this one. They are equal. They are the same. Also, we have this one and also this one. Those are also 4. Then we have this face and also this one behind this one. The whole of this. So you can see that in total, a box has 6 faces. The one on top, the one at the bottom, sideways, opposite. Also there are 2 and 2. So you expect 6 faces. Then edges, those are the lines joining the 2 corners or vertices. As long as you see 2 corners, should you look at that line joining the 2 corners? I have this one here. I have another one here. I have another one there. I have this one. That is what we call an edge. If you can see that this edge here is joining this vertex and the other vertex. If you look at that house, all those corners are called vertices. And then the line joining the 2 corners are what we call edges. Now, if you look at that box, we have length, then width, and then height. So for the case of a cuboid, that's what we expect to see. Length, width, and then height. So if you look at that book of yours, we have length, width, and height. Should you look at that box of chalk, that box of soap, then we say that box of tiles, still we say a brick. We have length, width, at the same time height. Now this is what I've been explaining about vertices, faces, and then edges. These corners here that you are seeing, those are the vertices. Then the flat surface is what we call a face. Then we all a plane. Then we have also edges. As long as you see a line joining the 2 faces, the 2 corners, or the 2 vertices, that's what we call an edge. Look at these bricks here. I have length, width, and then I have height. I have length, width, and then height. Length, width, and height. So this is our brick. Also look at different cuboids. This can be a box of chalk, a box of soap, a box of tiles, and say that this is our duster. Still, it is in form of a cuboid. So all those are cuboids. As long as you see faces different, not being equal in size, then those are cuboids. And then a plane surface is what we call, as I told you earlier, is what we call a face. Then these are all edges, vertices, and so on. So for the case of a tube, it has 6 faces, 12 edges, and then 80 vertices. The same thing applies to cuboids. They all have 6 faces, 12 edges, and 80 vertices. But the only difference between a tube and a cuboid is one. That for the case of a tube, all sides are equal. All edges are equal. But for the case of a cuboid, no. All the 3 dimensions, length, width, and height, are different in size. So that's why we say that for the case of a tube, it has 6 faces of the same size. But for the case of a cuboid, the faces are different. Okay, now for the case of total surface area and volume of a tube and a cuboid, now here you will learn how to derive the formula for volume and total surface area for each, a tube and a cuboid. And now we want to see, the case of a tube, it is a square prism. All faces for a tube, if at all you see a box with the square faces, if at all you see a house with the square walls, then you just know that that is a tube. Do you see a house with rectangular walls, with rectangular floors, and with rectangular ceilings? Then you just know that it is in form of a cuboid. Now we will ask you, Yusuf, how do we find the space inside the house? How do we find the space inside the box? Here, volume is found by getting the base area then times height. But the base of a cuboid is a rectangle, and the rectangle is length times width, the area, then times height. So here we shall say volume is equal to length times width times height, a cuboid. And then the volume for a tube is equal to length times width times height, but they are all equal. Length is the same as width is same as length, and at the same time height is the same as length, because all sides are equal. And then we say L times L times L, and I come up with the L cubed as our volume for a tube. A tube again is a square prism, and then a cuboid is a rectangular prism. Then, what is the total surface area of a cuboid? First of all, we have said that a cuboid has 6 faces. So you expect to find, but the 2 opposite faces are equal. So you expect to have 2 times length times width. Twice the product of length and width. Those are the two faces, the one at the bottom and one at the top. Then we have also the two faces having length and height. Then we have the two faces of dimensions, width and height. So the total surface area of a cuboid is equal to twice the product of length and width, twice the product of length and height, and twice the product of width and height. Now you may ask yourself, where does this formula come from? This is length and width. We have one at the top and one at the bottom. Then I have also height and width. We have the one at the front and even at the back. We have length here and then width. We have one here on top and then another one at the bottom. Then I have also height and width. It is here. We have height and then width. Height and then width. That is the second face, but it is the same face this way behind. And then we have length and then height. So you expect this face, again you expect another one behind there. So that's why you see us saying twice the length times width, twice the product of length and height, twice the product of width and height. If you look at that house, it has four opposite walls. The one at the front and another one at the back, even the side ones. One on the left, another one on the right. Then we have the floor and the ceiling, and those are the 6 faces of the house. Then for the case of a tube, you can see that it has 6 faces. We have one here, we have 2, we have 3, we have 4, we have 5, and 6. But now that a tube is a square prism, it has square faces, and the area of a square is equal to side times side. If at all the side of each square face is a, so we shall have side times side, squared, 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 and then we get the total of all these faces. A squared plus 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 a squared, I get 6a squared. Because we have 6 faces and each face has an area of a squared. So we come and we say that the total surface area of a tube is equal to 6a squared. And this is the net of a tube. Net is just a shape that we get after unfolding a solid. So when you unfold a box, you get such a shape. If you unfold still a box, you get a shape. As I told you that a cuboid is a rectangular prism, and then a tube is a square prism. Now I want to look at some examples about tubes and cuboids, but you need to master the other formulas of ours, that volume of a tube is equal to side times side, all L cubed, all side cubed. And the total surface area is equal to 6L squared. Now we shall come here and we ask ourselves, this is our example. A tube has a side length of 6 centimeters. What is its volume and total surface area? And now you need to ask yourself, how do I find the volume of a tube? It is L cubed, all L times L times L. And then the total surface area is equal to 6L squared, the area of each face times the number of faces. We have 6 faces, and the area for each face is L squared. Good enough, you have the length of each side, so you can be able to substitute in here and get the volume and total surface area. So for this case, our side is 6, so I'll have 6 times 6 times 6. Please, L cubed is not the same as L times 3, but it means that L is going to multiply itself 3 times. So 6 times 6 times 6. And then here we shall have 216 cubic centimeters. Please, friends, volume is measured in cubic units, and then area is measured in square units. So we shall again come here and we ask ourselves, what is total surface area? You have here the length. So we shall say 6 times L squared, 6 times 6, and I get 216 square centimeters. Then also number 2 says that if the surface area of a tube is 216 square centimeters, what is its length? What is its side length? Now here we shall come and we say that the surface area is equal to 6L squared. The surface area of a tube is equal to 6L squared. But you need to come on your question and extract important information. Do I have the total surface area? It is 216. So in my formula here, how many unknowns do I remain with? I have total surface area tick, and then I remain with L. So it means that I can easily substitute. And then here we shall have 216 total surface area is equal to 6L squared. Now here, to make L squared the subject, I'll divide by 6. I'll divide the 6 on both sides. Here 216 divided by 6, and then by 6 L squared divided by 6. 6 divided by 6, I get 1. So I remain with L squared. 216 divided by 6, I get 36. So after getting that, you'll come here and you say that here that L squared is equal to 36. Now for you, if you want to make L the subject of the formula, friends, if you see L power 2 in a variable with the power 2, what you need to do is to introduce the square root symbol on both sides. And here the square root of L squared is L, and then the square root of 36 is 6. So we shall come here and we conclude by saying that our L is equal to 6 centimeters. But go ahead and give conclusion. Then you'll say that the side length is 60 centimeters. Then we have also another example about now cuboid. A cuboid has dimensions 8 centimeters by 5 centimeters by 3 centimeters. Find its volume and total surface area. The moment you see this, that means that here we shall have length, width, and then height. This is our length, then this is our width, and then this is our height. So we shall come and we ask ourselves, how do I find the volume for a cuboid? It is length times width times height. And do I have length? Yes. The length here is 8 centimeters, and the width is 5 centimeters, and the height is 3 centimeters. And then we shall come and we substitute there for L, W, and H. 8 times 5 times 3, we get 120 cubic centimeters. And then here also we shall look at total surface area. As I told you earlier that a tube has 6 rectangular faces. The one at the top, another one at the bottom, the one at the front and the back, and one on the right, and even another one at the back. Right, and one on the left. But you have to know that these are the 6 faces. 2 plus 2 plus 2, those are 6 faces. So here we expect to have, what is our length? It is 8. What is our width? It is 5. So I come here and I say that 2 into 8 times 5, and that is length and width. So here we shall have 2 into 8 times 3, length and height. Then lastly 2 into 5 times 3, that is width and then height. So we shall get here 2 times 40, I get 80. 8 times 3, I get 24 times 2, 48. Then 5 times 3, it is 15 times 2, 30. Then here we get a total of 158 square meters. Now here we have our scenario that Jessica plans to paint outer walls of his house, which has 3 windows and 1 door. The house measures 12 meters by 8 meters by 4 meters. I have explained that this is our length, width, and then height. While each window measures 0.9 meters by 0.6 meters, and a door measures 2.1 meters by 0.8 meters. The moment you see that 2 dimensions, then just know that it's rectangular in shape, because a rectangle has length and width. And she plans to paint the house using 1 liter tin, and each costs 15,000 Uganda shillings. A tin can paint 5 square meters. Then we have here our task. Calculate how much money she will need to paint the whole house. Now, friends, here you can extract, you can here come and you ask yourself, when we are painting a house, we don't paint the floor and the ceiling sometimes. But here, because they are saying paint the 4 outer walls, so we are painting the opposite walls. And for more information also, when we are painting the space where the window is, the space where the doors are, the space where the windows are, is not painted. So as you are intending to find the area, you have to make sure that you find the area of those walls, then the area for the doors and the windows, the space covered by the windows, the space covered by the windows and the doors shouldn't be part of the painting surface. So we shall come here and we say that length is 12, width is 8, and then height is 4. And you need to come and you say that when we are painting the house, we paint the opposite walls. But remember the floor or the base of the house is length and width. And the base or the floor is the same as the ceiling in size. So you have to make sure that you don't paint the base and the floor and the ceiling. So for that case, we shall consider length and height, and then width and height. But those are the two faces. And then when it comes to painting outer walls, I expect to paint 4 walls. The one at the front, another one at the back, then the one on the left, and another one on the right. So those are the 4 walls of the house that we are going to paint. The 2 walls to make 6 walls. We would have a floor and the ceiling, but we are not painting the ceiling for that case. So we shall just come here and we substitute, and here we get 2 into 12, the height times 4, which is the height. 12 is the length, and then 4 is the height. Then we have 2 into 8, which is the width, then 4 is the height, and then I get 96, then plus 64, I get 160 square meters. Now, that is the area for the 4 walls. And then we say that the area for the opposite walls, 4 opposite walls, is what we call the lateral surface area. So as you see LCA, LSA, that's what we call lateral surface area, the area of the 4 opposite walls. Now, after finding the area of the walls, I have to come back and I ask myself, good enough I've seen that I will not paint the space or the surface where the windows are. Just I'm painting the walls. It means that I'm going to find the area of the surface covered by the 3 windows and the surface covered by the door. So I'll just come here and I say that the window here has dimension 0.9 and 0.6. So I'll come and I say that length times width 0.9 times 0.6 times 3, I get 1.62 square meters. That is the area for the 3 windows. And then here the area for a door is length times width, and 2.1 times 0.8, I get 1.682 square meters. So the area of walls that will be painted. So here I'm going to consider the 4 walls, but what I will not paint is the space where the windows are and the door. So I'll just come and I get the area of the 4 walls minus the area which is not going to be painted. Get the area, the surface area to be painted. So here we shall have 160 minus the sum of the area of the windows and the area of the door, and I get 156.7 square meters. And then how will you find the number of tins? And remember here they are saying each tin can paint 5 square meters. Now come here and I ask myself, if I want the number of tins, I'll get the area of walls to be painted divided by how much area can one tin paint. So I'll get area of walls to be painted divided by the area each tin can paint. 156.7 square meters divided by 5 square meters, I get 31.34. Now please don't end here 31.34. No, you cannot go to maybe to the hardware and you buy a half a tin. No, they don't sell half tins. Instead, if you want 31 and another tin which is not full, but they don't sell half tins of paint, at the hardware. So you'll buy 32 tins, you paint, even you remain with some paint in the tin. But it's better to have much than having less. So friends, in case whether a number is less than 5, whether a number is greater than 5, now here when we are rounding off, we are not depending on a number greater than 5, a number less than 5. No, as long as here 31.34 tins, but they don't sell half tins. So here you'll say approximately 32 tins. And then your total cost. I'll ask myself, how much is each tin? It's 15,000. So the total cost of 32 tins will be 32 times the cost of each tin. And for that case, I get 480,000 shillings as the total amount of money that is needed to paint the whole house. Then also we have here another example about steel painting. And as I told you that in this video, you'll learn how to apply the formula for finding the total surface area of a tube and a cuboid to solve the real life problems. Now here you can see that a family decides to paint inner walls of its living room for New Year celebrations with a budget of 400,000. The room is 5 meters long, 4 meters wide, and 3 meters high. The room has 2 painted doors in the middle of the walls opposite each other. Each door is 2 meters high and 0.75 meters wide. The room has 1 painted window in one of the side walls, which is 1 square meter, 1 meter square. And the painter charges 800 per square meter painted. And for every 10 square meters painted fully, it consumes 4-liter tin, which he sells at 70,000 shillings. Now the task: establish the computations to find out if the budgeted money could be enough for this work. But remember, in his budget, for him is having 400,000 shillings. And as I told you that when we are painting, we consider the lateral surface area, the side walls and the opposite walls. The wall at the front and another wall at the back. Those are the opposite walls. Then side walls on the right, at the same time on the left. So here, as you can recall in our formula earlier, that 2 into L times H plus 2 into W times H. I've told you that we don't paint the floor and the ceiling unless you are told to. And we are painting just inner walls. When we are painting inner and outer, then it means that we shall paint 80 walls. 4 the same, and the other 4 also the same. But for the case of this, we are painting the inner walls only. So you'll come here and you say 2 into 5 times 3 plus 2 into 4 times 3. And then here we shall come up with 30 plus 4. I get 54 square meters as the area of the walls that must be painted. Then the area of a window is 1 square meters. And again, here they are saying that it has 2 doors which are painted. It means that on those walls where windows are and where a window is, you are not going to paint there, because the windows and the doors are not part of the painting. You are painting only walls. Where the windows are, we shall not paint there. Where the doors are, we shall not paint there. So to get the area that will not be painted, the surface area that will not be painted will be the area of the two doors as the area of one window. 3 plus 1, I get 4. So for that case, it means that the area of the walls that will be painted will be the area of the 4 walls minus the area of 2 doors and 1 window. And I get a difference of 50 square meters. Then how do I find the number of tins? Come back and check. They are saying for every 10 square meters wall painted fully, it consumes a 4-liter tin. So that means that to paint 10 square meters, you need only 4 liters of the paint. But they're not saying 1 liter. They sell a tin of paint, and its capacity is 4 liters. So we shall get area of the walls to be painted divided by the area that each tin can paint. So 50 divided by 10, I get 5 tins. So it means that here we shall come and we shall say that total cost will be 32 tins is equal to 5, the number of tins, times the cost of each tin. And here the cost of each tin is 70,000 shillings. So it means that we shall need here a total of 350,000 shillings as our total expenditure on tins, all on paint. Then it does not end there. Also, we need labor. That for every square meter, he needs 800 shillings. How many square meters do I have? 50. They are here. So I'll get 50 times 800 to find how much I need to spend on the labor. And then I get here 40,000 shillings. So the total expenditure will be the amount spent on paint plus labor. I get 390,000 shillings. So, which conclusion are you going to give? You must respond to the task to find out if the budgeted money is enough. Please go ahead and go back to the question before you just write a conclusion. The budget was having 400,000 shillings. And I've seen that the total expenditure is 390,000 shillings. So is that money enough? Yes, the money will be enough because it is less than what they had put in the budget. So friends, we want to appreciate you so much for watching. Do not forget to subscribe, like, and share. Our YouTube channel is the Mathematics Connect. And again, we have also our WhatsApp group, which is Mathematics Connect. Thank you so much for watching. We meet in the next video lesson.